So let's begin this course with a little overview of Kubernetes. Kubernetes, also known as KA, is an open source system for automating, deploying, scaling, and managing containerized applications. The name Kubernetes originates from Greek, meaning huntsman or pilot. Kubernetes 1.0 was released on July 21st, 2015. It has been a long while. And how far Kubernetes has come through. Let's discover more details about Kubernetes. Kubernetes is no longer maintained by Google. It was given to Cloud Native Computing Foundation and helped promoting the use of container technology. The source code for Kubernetes is hosted on GitHub, an active open source project. The code is under license Apache version 2.0. Kubernetes as a software is available for free. One can contribute to the code with some coding skills with Go language in general. So let's begin this course with why do we need container orchestration? And orchestration is a way of automating the operational efforts required for managing containerized applications. Orchestrator automates applications, scale in, scale out, networking, deployment of containers. There are more functionalities associated with orchestrators, which we can go in detail in the advanced modules. The key benefits of using container orchestration are that it simplifies operations for containerized applications, improve resiliency by automating scaling, failover, and restart of containers in typical cases. Orchestration tools can be integrated with different applications to improve the security posture of the application, optimize the cost of deployment, and provide capability to deploy containers on hybrid cloud and also reduce operational overheads. A brief introduction about learning about Kubernetes would be one of the key steps if you are into managing cloud-native applications in production. Kubernetes also have competitors. Some are open source, to name a few: Docker Swarm, Amazon ECS, HashiCorp Nomad, etc. Major cloud service providers offer Kubernetes-based services like Google provides GKE, Azure provides AKS, Alibaba's ACK, and Amazon's EKS. We will talk a little more detail about these in the advanced modules. Kubernetes ecosystem is evolving and it has a number of tools, services, and it is supported by the best of the great practitioners in the community. The abstraction in Kubernetes allows you to deploy containerized applications to a cluster without tying them specifically to individual machines. To make use of this new model of deployment, applications need to be packaged in a way that decouples them from individual hosts. They need to be containerized. Kubernetes automates the distribution and scheduling of application containers across a cluster in a more efficient way. Now, talking about Kubernetes cluster itself, it consists of two types of resources: the control plane, which coordinates the cluster, and the nodes that are workers that run applications. Basic terminology: nodes. To run Kubernetes, you will require a Linux machine. It can be a physical machine or a virtual machine, which is called nodes in Kubernetes, that runs your container application. The node can be physical or virtual machine on a cloud provider like EC2 instance. There are two types of nodes: master node and worker node. Pod. Pod is a group of one or more containers with shared storage and network resources and a specification for how to run the containers. The worker nodes host the pod that are the component of the application workload. The master node are responsible for maintaining the state of Kubernetes cluster. Now coming to basic terminology about control plane. These components are responsible for maintaining the state of the cluster. They are installed on the master node. As an administrator, you interact with the control plane components. The control plane components make global decisions about the cluster. For example, scheduling, as well as detecting and responding to cluster events. Kube API server is one of the control plane components, one of the most important ones. It exposes the Kubernetes API designed to scale horizontally. We will talk more about these in the next few slides. But to give you an overview, etcd, a third-party database used by Kubernetes project, consistent and highly available key value store used as Kubernetes backend store for all cluster data. We will talk more about the role of etcd and also how it interacts with the other components in the next few slides. Kube scheduler watches for newly created pods with no assigned nodes and selects a node for them to run on. Kube controller manager runs controller processes, types of controller, node controller, job controller, and there are many other. It's a big binary and can be broken down into a number of components. Cloud controller manager embeds cloud-specific control logic. When we talk about the basic Kubernetes cluster, when you deploy Kubernetes, you will get a cluster, right? So a Kubernetes cluster consists of a set of worker machines called nodes that run containerized application. Every cluster has at least one worker node. Here is a simplified visualization of Kubernetes cluster. It has 4 nodes. Kubernetes cluster with all necessary components. For small sample projects, you can use Minikube, which installs all Kubernetes components on your local machine. It's not recommended for production. If you're deploying your first Kubernetes cluster, I would suggest you go and explore Minikube. For this course, we have some advanced modules which will help you understand how to install your first Kubernetes cluster through Minikube. For production, you can use cloud offering, Amazon EKS, for example. Now let's dig deeper into the role of each of the components, which we talked about in the earlier slide. So the basic role of Kube API server. Kube API server is a REST API. It exposes all the Kubernetes features. Kube control is a command line tool which facilitates the interaction by calling this REST API. It is implemented in Go. Its code is open source under Apache 2.0 license, hosted on GitHub. It is a single entry point for all operations issued to the orchestrator. By sending instructions to Kube API server components through HTTPS protocol, you can create, update, or delete a container. Kube API server is designed to scale horizontally. That is, it scales by deploying more instances. Kube API server is built according to the REST standards, and it is used various methods of HTTP protocol like GET, POST, PUT, patch, delete. Using REST standards bring a lot of flexibility. For learners, I would recommend to go through the basic details of these standards and get acquainted with REST API. Let's talk more about Cube API server. So when you download the Cube API server, the Go compile binary is executed on a Linux machine. There are a number of resources bundled in the binary. All resources are related to container management, compute, and infrastructure in general. You can run several instances of Cube API server and balance the traffic between those instances. Cloud service providers will install and configure all Kubernetes components properly, exposing the endpoints of Kube API server, abstracting the details. Kube control is a command line tool used by Kubernetes. It is HTTP client integrated to interact with Kubernetes. In our hands-on section, we will explore how to install Kube API server, but for this section, we only provide an overview. We'll talk about Kube control command line tool. Each time you run a kube control command, the kube control command line tool will look into the kube config file. The kube config file, which carries information about the kube API server endpoints, its ports, clients, certificates used to authenticate it against kube API server. Some of these commands are displayed on this slide, commands which you will type every day on this utility. To config view, get pod, run test pod, delete pods. These are commands which you will get acquainted with when you start using this utility. Kube control also supports declarative syntax. What it means is that you can write a JSON or a YAML file. Most commonly, YAML is used with kube control though. And again, if you're not acquainted with YAML as a syntax, please, I would recommend to get some hands-on on YAML. Now let's talk about etcd data store. etcd data store is part of the control plane. However, it is not part of the Kubernetes project as such. Kube API server component is dependent on a distributed NoSQL database, that is etcd. etcd is also an open source project. It is available on GitHub under Apache license 2.0 and written in Go. It is used to store the state of the cluster, such as number of containers on which machines, name of the pod, the Docker images they use are stored. Each time you call Kube API server, it reads, write data to and from etcd. If you use cloud services like Amazon EKS, Google JKey, it installs a pool of servers which run this database on it. For an on-premise, you have to manage it yourself and it should be on the master node. Now let's talk about Cubelet. Cubelet is a worker node component. Cubelet is part of the worker node and it is the most important component of the worker node. The worker node has a container engine installed on it. Most commonly, it is the Docker daemon, but it's not limited to that. You can actually have another container engine as well. Cubelet interacts with the Docker daemon on the worker node. The Cubelet is run on the host machine and makes use of the config file kubelet.conf to know the endpoints of the Kube API server component and local Docker daemon. So Kubelet acts as a bridge between Kube API server and the local Docker daemon. It uses the watch mechanism to run or delete against the worker node at scale. Now let's talk about kubeproxy. Kubeproxy is also a worker node component. Kubeproxy is important, so we expose the ports to one another in the Kubernetes cluster or to the outside world. Each worker node requires a running kubeproxy so that the pods running on them are accessible. Service is a Kubernetes feature which is implemented at kubeproxy. Kubeproxy also communicate with the Kube API server. Let's talk about Kube Scheduler. It's a control plane component. Kube Scheduler, as I mentioned, is a control plane component. It should run on the master node. It is responsible for electing worker node out of those available to run a newly created pod. Kube Scheduler interacts with Kube API server at regular intervals in order to list the pod not scheduled yet. So at creation, the pods are not scheduled. The pod which is not scheduled is registered in the etcd without a worker node assigned to it, and the state is pending. The pod objects as a property node name. When the pod is assigned a worker node, the property is set and the pod is scheduled. The Kube Scheduler runs an algorithm to assign the node name for the pending pod objects. Let's talk about Kube Controller Manager. Kube Controller Manager is part of the control plane. This component is used for maintaining consistent state of the cluster with one described in the etcd. Kube Controller Manager implements a lot of functionalities. Some of them are described below: node controller, namespace controller, endpoint controller, service account controller. So it's a big binary, but it can be implemented in parts and pieces. As it is part of the control plane, it is installed on the master node. If you are using cloud service provider, they will install it for you seamlessly. Now let's talk about the deployment models. We have talked about the master nodes, the worker nodes, the components on the control plane, as well as on the worker node. So this architecture view would look more familiar now. So there can be various deployment models for your cluster. I will discuss these two deployment models where you have single master node cluster and a multi-master node cluster. So obviously, it is evident either you can have one master node where you can host all these control plane components, or you decide to distribute your master node into multiple nodes, and it also enhances the resiliency of your Kubernetes deployment. Now, in the single master node cluster, the master node is the single point of failure. A single etcd instance is running and it cannot scale effectively. By using a multi-master node cluster, we eliminate the risk as we are running multiple instances of your worker nodes and master nodes. In a multi-master node cluster, you will need a load balancer on top of your Kube API server in order to spread the load evenly. There are other deployment configurations as well, like spreading the control plane components across the dedicated host, which we can talk about in the advanced modules. So now we are at a stage where we can think about how to adopt Kubernetes. There's a basic information. Before actually starting to install Kubernetes, I would like you all to think about the leader's role in adopting DevOps Kubernetes and long-term thinking to sustain the results. So obviously you have to think about, the application you have, the containerized application, how that will scale, what kind of deployment models would be preferable. Would you like to do it on premise or on a cloud infrastructure provider? If it is on the cloud infrastructure provider, how do you choose based on the various cloud services available? Which one is more suitable for your needs? So think about all these aspects. How would you adopt Kubernetes? Obviously, there are three parts of this problem. The first is, again, as we mentioned, the architecture, the technology, the tools behind your implementation. Then what processes you would need in order to ensure that you seamlessly adopt, containerizing your application with Kubernetes orchestrator. And the third part of this is people. What are the people skills which are needed? How do you upskill your people in order to ensure that you will be able to sustain that long-term thinking of building resiliency and a cloud native application landscape within your organization? In the next advanced courses, we will talk about different things, basically how you can install your first Kubernetes cluster based on, let's say, your Minikube. We will also provide you some reflections on, how to implement it with various cloud providers. There are more advanced topics when working with Helm charts, releasing a software to use Kubernetes using Helm charts, and authorization and introduction to rollback access control. This will be part of your next level of learning. But for now, I would like you to go through this module and also try to understand the basic terminologies for Kubernetes. Thank you for being here.